All right, here we are, hopefully finishing up chapter 6, picking up with number 11. We're skipping number 10. We've got a graph here, and it's just a simple domain question. What is the domain? So remember, domain is your x values. So we're looking at our time here. So the lowest time this graph is ever going to use is 0. And the highest time this graph is ever going to use is 5. So we know we're going 0 to 5. 0 to 400, that's the range. That's my y values. So are we looking at all real numbers or all integers? Integers, remember, are just the whole numbers. It would only be if we were using 1 second, 2 seconds, 3 seconds. We're using all the numbers in between as well. So that makes A your answer. All right, number 12. There goes Ruby being noisy again, sorry. Number 12, I'm just looking to graph this thing. So I'm just going to plug in x squared minus 2x minus 8 and go look at my graph. I can change my window, or remember earlier we said if you just hold down your center button, you can kind of move this around so you can see what you need to see. But if you're just kind of judging based off even basic ideas of how it looks, G is my answer. Okay? All right. Number 13, we are also going to, nope, just kidding, not number 13, number 15. So number 13, what are the solutions to the equation? Well, it's got to equal 0. Quadratics with squares need to equal 0. So I'm going to see if I can do x minus 5 squared. I'm just going to subtract 2 here. Equals 0, okay? When I go do this, let me add a new graph page. Let's just see what this looks like. X minus 5 squared. Get out of your exponent. Whoops. Need to get back up here and finish. X minus 5 squared minus 2. Let's see what that graph looks like. Okay, so now if you start looking at this, it's a little bit strange because my answer choices are not normal numbers. It's the square root of 7, negative 5 plus the square root of 3. So let's just go look and see where this 0 is. Come on. It's going to take me just a minute to get there. All right. My 0 is 3.59 is one of them. The other one, all the way back around, is 6.41. Now, I know what you're thinking. Well, that's not helpful at all. Look at my answer choices here. Well, let's go look at a calculator page. We want these two numbers, right? So let's test out, let's just start out with the square root of 7. If I do the square root of 7, 2.64, that's not either of mine. And then negative 2.64 doesn't match. I'm betting this negative is not going to give me these two positive numbers. So let's check C. 4 plus the square root of 5. Remember, this is 4 plus the square root of 5, and then it's also 4 minus the square root of 5. Neither one of those matches the two numbers I'm trying to find for my zeros. So just to confirm, 5 plus the square root of 2, 5 minus the square root of 2, 6.41, 3.59. They rounded it, 8.5 rounds up to 9. So that's easy way to do this. Number 14, I really think is another one of those reading questions. We have this function. It says, between which two numbers is there a solution? Well, I have a solution right here, and I have a solution right here. So is there a solution between negative 4 and negative 3? No, there's not. How about between negative 2 and negative 1? No, there's no solution there. Negative 1 and 0? Yes. 0 and 1, there's no solution. So it's worded kind of oddly, but it's really just still looking for that intersection. All right, we're skipping 15. Number 16, it equals 0. So remember, from a table to find the solution, it's where the y value equals 0, okay? Because if I was to graph those 2 points, negative 1, 0, and positive 3, 0, those would be your x-intercepts on that graph, okay? So your answer is -1 and +3. Don't do the sucker. That's your sucker answer right there. 0, -3 would actually be down here. That's your y-intercept. That is not a solution, okay? Number 17, they've graphed it for you, and it says on the grid above, graph the new one. So let's see a new graph page. I'm going to go ahead and graph the original 1/2 x squared, and then I'm going to graph the new one, 1/2 x squared minus 8. And notice, since my graph is only going down to -6.67, you're not really seeing that y-intercept, but I can kind of slide it up here a little bit, and now I can see everything. So if I graph this, I have a y-intercept at -8. I could use graph trace to actually see that exactly. I have it at x-intercept at 1, 2, 3, -4, and over here at +4. And so there's my basic sketch of this thing, okay? Not anything too crazy fancy. How can you use your graph to find the solutions? It's the x-intercepts, which are +4 and -4. Okay? Solving it algebraically, I'm not gonna lie to you guys, don't do this algebraically, okay? If I was giving you a test and I took away your calculator, then sure, do it algebraically. But honestly, you have a calculator and you want to make as high a grade on this STAR test as you can, use your calculator. Do not be a hero, okay? All right, so quadratics, remember all those words that mean the same thing. Remember to use your calculator, and it has to equal 0. So if at any time you have a function that doesn't equal y or doesn't equal 0, you've got to make it equal 0 first. All right, that's it for chapter 6 and quadratics.